this step, like the one I'm going to show you today, where it's graphing, there's just one extra little layer that I need to add after. But this is basically it. Like you read, you write, you graph. And then there's one extra layer that I need to add. But so today and tomorrow, for sure, we're going to spend a bit more time graphing these word problems. And before I get started, just keep your finger on here. You don't even need to follow me here. I will just show you. I touched on that when we were starting. I'm going to keep my finger on 54 there. Just so you know, when there's no context, no word problem, all four quadrants are applicable. For word problems, for us, it's going to stay within the first quadrant. Okay, we're going to stay there. So keep that in mind. So if we go to 54, we will quickly copy the inequalities down. Okay, so we already defined variables. I want to use my space wisely here because I need it for the graph. We're just going to let X and Y be the hours at Canadian Tire, and Y is the hours at Wendy's. The implicit constraint is your X, Y is greater than or equal to 0. You can't have negative hours. And let's write our system of inequalities. We knew that X plus Y, like the number of hours at both, could be at most 30 hours per week. We know that one already. This is inequality 1. How about you label that? Inequality 1. This is inequality 1. Okay. Then we know that minimum of 9 hours at Canadian Tire. So that's X is greater than or equal to 9. That's inequality number 2. So we'll go up here and label that inequality number 2. Emily would like to earn at least $225 per week. That is inequality number 3. So we would go 1145 X plus 1250 Y. That has to be greater than 225. That's inequality number 3. And quite like I won't always ask you to fully graph everything. Okay, sometimes this will be it. Like just come up with inequalities. Do you know what you're doing? I might give you 15 different inequalities, and you have to select the ones that apply to the question. There's another way that I might test you on it. So I might fool around a little bit with the way it's pointing, right? So you have to be careful with that. All right, so we've got our 3 inequalities, very important. Now it says graph all possible solutions. So we're going to focus on this right now. And you will realize that a lot of it is going back to what we did at the very beginning. So let's do, I'm going to do, be very conservative with my spacing because I need to graph at the bottom here. So let's do the inequality, the first one here. Inequality 1. So no matter what you do, be concise and be clean about how you do your work. What did we do before? We found out the intercepts, right? This one is actually very easy. X and Y just have a coefficient of 1. So it's X is equal to 30. So it's 30, 0. Y is equal to 30, 0, 30. Boom, you're done. That is important for graphing purposes. Okay? Next, you rewrite your inequalities. So we will go Y is less than or equal to, that X comes over subtracting. Okay? So we go negative X plus 30. And that's what you need. You need this because later when we find the points of intersection, you want to graph all the boundary lines and find where they meet. That's why I do this. Another reason I do this is to easily find the solution region. So this is going to be a solid line, true region, is below, I will therefore shade above. So I circle that. That's what I'm going to focus on when it's graphing time. Okay? Boom, that's it. I'm done with inequality number 1. Now let's do inequality number 2. X is greater than or equal to 9. This is a special case. Vertical boundary line at 9, 0. So you don't need to rewrite, you don't need to clean it up. If that was the case, then you would do it. And so we know that this is solid. The true region is, if it's X, it's either right or left. True region is to the right. We will shade the exact opposite. This is where we're going to shade. We're going to shade left. Done. That is cleaned up. Okay. So I kind of have everything concise, as concise as possible. And it just works out that I have the third inequality here. I'm going to do the work right underneath it. This has X and Y variables. So I'll go X-intercept, Y-intercept. And this would be, this turns Y, right? 0 for Y, so this is gone. So you're at 1145. X is equal to 225. You divide both by 1145. Don't let decimals throw you off. Decimals are our friends, not enemies. Is that Saving Nemo? Can't remember. 1965. So 1965, 0 is our x-intercept. We go back here. 1250 y is 225. Divide by 1250. There's a big chance if you have to take math in college or whatever that this kind of stuff is always going to be required of you to do this kind of algebra, finding the intercepts, all that stuff. Clean it up. It's a bit messier. Let's rewrite this. So you go 1250 y greater than or equal to, bring the 1145x over to that side, negative, plus 225. Divided by 1250. And here it gets a little messy, okay? So let's see. This is actually a finite. Watch what I did. When I divide this and this, I actually get a finite decimal. So it's okay to write a decimal there. But I know it's not gonna look pretty. I will do this just to show you that I want you to use all decimals when you're typing this into your calculator. So, right, it divides here. And 225 divided by 1250, we know is 18. So that one, no problem, just leave it like that. But if it wasn't, if it was a decimal that never ends, infinite decimal, right, then I'll also write this as a fraction. Okay? All right, solid. True region is where? If it's greater than, true region is above the line, above the boundary line, we will shade below. Circle that. I will give you a lot of space on a test to do these kinds of things, okay? Make sure you have that written down. And now we're going to proceed to the graphing portion. Have a ruler. Zoom out. I don't know how your spacing looks like. I'm going to try to get the graph in here. So I'll go like this. I can make that work. Let's do a labeling first. X would be hours at Canadian Tire. Y would be hours at Wendy's. So you've got units and labels. And now the critical part is look at your values, your intercepts, to determine what your scale should be. So I look at the x-intercepts. The greatest is 30. So I'm going to make sure I fit 30 in the x-axis. I look at the y's. The greatest is 30 as well. So if I make sure I include 30 here, I'm fine as well. So I'm going to go up by 10s here and by 10s there. And I will use my ruler to help me out. Okay. Spread it out if you can. This would be 10, 20, 30, 40. Okay. I used my ruler to space it out equally. So this is 10, 20, 30, 40. And then here I've got 10, 20, 30, 40 doesn't fit, so I'm just going to leave it like that. So make it work. Make it fit your graph. So go up by 10s, go up by 10s. And let's plot this thing. So I go 0, 30, 30, 0. And I'm also going to tell you most examples are solid lines when it's word problems. Every once in a while there is a dashed line, but not often. So that is my x plus y line. So what I do is I just go like this and I go x plus y is less than or equal to 30. You will probably have to be ready to erase every once in a while and just move your labels. Then I have 9, 0. 9, 0 is right about there. That's 9, 0 right there. And that's a vertical line. So then you just go, I kind of try to make sure it's parallel to my y-axis. There you go. And this is x is greater than or equal to 9. Then you've got 1965, which is so close to 20. I'm just going to make it be just off there, just short of 20. And then 018, which should be right about there. Right, 018. And it's okay to go off the grid with your labels if you must. So this is, it's up to you how you want to label it. I'm going to go 1145x plus 1250y is greater than or equal to 225. Notice that I'm staying in the first quadrant, right? My lines aren't running out or past it. I actually stop. Okay. And now I'm going to proceed with the shading portion. The very first line I have to shade above the x plus y. So I go here. And you know, I'm going to suggest this to you. how about you just do a little bit of shading at first? Okay, this is gone. And then you go through your list, right? And the vertical line, I'm told that I shade left. So I go over here, I shade left. And then the last one, I'm told to shade below. Just to check, it's like, okay, if I were to do this shading, this is gone, this is gone, this is gone, I'm left with a solution region there. And then you're like, okay, I'm not going to shade the entire thing, so I think I'm doing all right here. Okay, so now I'm committing to and again, you don't have to make it too dark, right? Just let me know where the shading is. I want a clean graph, but I don't need a perfect shading, you know what I mean? Like, don't spend too much time on that. So you have to label your solution. We call this the solution polygon sometimes, solution region. It's the same. It is a polygon if you think about it, right? So if you ever see anything like that in my workbook, it's talking about the same thing. So all of this is D, okay? You're graphing all possible solutions here, which are found in this polygon right here. Almost, it looks like a trapezoid, right? Upside down. Next, E. State a possible solution. It doesn't say the solution, a possible solution. So just go to your graph. Could you pick 20, 0? You actually could pick 20, 0. You could pick the actual x-intercepts if you wanted to. Okay. You could pick anything in the solution region. So I'm going to go 25, 2. Something like that. I'm just going to make a little dot there. 25, 2 would work. Which means 25 hours at Canadian Tire and 2 hours at Wendy's. That's what that means, okay? It has a meaning in this context. It's not just a point, right? And last, find the POIs. And I want you to all do this, okay? I want you to type all 3 into your calculator. How many POIs do we have, guys? We've got 1, 2, 3, 4. So the x-intercepts count in a word problem. So you just have to find these 2 here. Do you remember how to graph a vertical line on the calculator? 9, 9, 9, 9, 9, right? So 9 times. And then x minus 9 in this case it would be. I'm going to type this in. I think, you know what I'm thinking? It's kind of, I don't like to think about it, but I feel like there will be a time where I will have to teach using shorts, like short clips, because students probably can't handle x minus 9. So it's the opposite of what you have. And then the other one is kind of tricky, but don't fear it. You've got a calculator. So it's negative 11.45 divided by 12.5, right? X plus 18. Oh, it's over here. Move. 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 Anyways. Graph. I don't see anything. Well, we know we're in quadrant 1, right? So maybe use what you have here. Let's go to 40 and our x max. I'm just going to have -5 in the x min, -5 in the y min, and 40 in my y max, right? Use what you already know about this graph, about these lines. Hit graph, and there you have. And it matches what we have, right? So we need to find these two here. Second trace, intersect. I'm going to find the intersection between the blue and the red. So I hit enter on the blue. It jumps to the red. I hit enter again, and then enter one more time. And you get 921. Okay, I'm going to write that down. 921. That's a calculator point that I used my calculator to find that one. Now I'm going to find between the red and the black. So I'm going to go second trace 5 or intersect. I'm going to jump lines. I jumped up and down arrow to get to the black line. Hit enter. Jump until you get to the red one. Enter, and then enter one more time. And you get 9.756. That's also calculator. And then the other ones I'm just going to read. This one I know is 19.850. I just read it off my graph, this one. And then 30, I also read it off my graph. I don't care how you find them, but don't put more work on yourselves if you can save some work, some time, right? But I don't know if you remember when it's discrete, we have discrete, in this case it's continuous data, right? So we don't have to round our points of intersection, okay? I'll make a note. Continuous data, don't round POIs. How do I know it's continuous? It's because it's hours, right? X and Y represent the number of hours at each job. Okay. Okay, now we're done. I will ask you to try page 52. Make sure you use your space very wisely, okay? And page 49. And before you pack, page 52, guys, we already wrote the inequalities. You're listening? Don't try to reinvent the wheel. Page 52, we already wrote the inequalities. So I'm going back here. Remember the DJ question? When you were still sleeping early in the morning? We already did this, so just go get the inequalities. I would say try to write them again without looking, just to practice. But before you graph, please go get them before you graph. Don't make a mistake and then graph and then it's all wrong, right? Please try at least 52. 49, I ask you will have to read it and come up with your inequalities yourselves. So that one is a little bit trickier. And then we'll take it from there, okay? Thank you, guys.